Hello everybody and welcome to this video lecture on Octave Spice, and we are in chapter 2. So chapter 2 was basically let's look at the contents here. So chapter 2 was GNU Octave as a calculator, and we are in matrices and vectors. So we already in the previous lecture saw how to define matrices and discussed a little bit of how everything works, hopefully in the obvious way. With matrices, I mean matrix multiplication, division, summing, identity matrices, and so on. And now we are going to cutting and pasting. So we are now in the page bottom of page 12 and the beginning of page 11 and beginning of page 12. So this is probably something that you haven't seen in too much, at least in a linear algebra course. So let's if I go too fast, then you can, of course, since this is a recorded video, you know what to do. You can watch this again, for example. So let's AB some matrix now, and it turns out that we want to refer to its rows and its columns. So we would say that let this thing here be the third or in general ith row or column. And so we need a notation for this. And this notation, what we have here, I use so-called bullet notation. This is a typical mathematical notation. So if I look at the A, and then there is an I, and then a bullet, big dot after it. This means that I am looking at the ith row of this matrix. The way to understand is that I, for example, 1 is fixed. That's given. So if I am looking at A1 bullet, it means I'm looking at the first row. And one way of understanding is that this I is a fixed, it is what it is. And bullet means that something runs free. So the columns run free. So if I fix a row and let the columns run free, it means that row, yes? And the other way around, for example here, if I have A bullet J, it means that the column J is fixed and the rows, whatever they are, they run free. Okay, so this is the bullet notation. How do we do this with Octave? And Octave, it works very similar way. So this is so-called colon notation. So this AI bullet becomes A in parentheses I. So this is the row that's fixed, and then we have the columns running free. So the bullet comes, it's actually a colon. Okay, so now we have two notations, and you may say that this is kind of too much. Why not just have one? Well, that's a good question. It's a good criticism. The reason for this is that, I follow the typical convention that we have mathematical notation on the one hand, and then the programming notation on the other hand, and we have these two different notations side by side. I don't know if this is good or bad. The mathematical notation is sometimes more convenient, more compact, but of course then there are this problem or the heavy duty of learning two notations. But this is the way it's usually done, so I don't want to change the tradition at this point. Okay, in any case, to understand what is just said, let us have an example. So here we have example 2.11, matrix rows and columns via colon. Okay. And so here is the conversation. Let's have an Octave here. Apparently I had it open already. Let us start anew. Sometimes it's a good idea to turn it off and on again, as the IT crowd said. So I exit GNU Octave and I start again. So what do we have in this example 211? So let's have just some matrix. It's like this. Now I try something courageous. So I just try to copy paste. Let's see if it works. So here is the first row like this. And the second row like this. Let's press enter and okay, it worked. So I could copy paste from PDF file and it worked. That's not always the case. Sometimes it works, sometimes it doesn't. So this is our matrix. So it's 2 rows and 1, 2, 3, 4, 5 columns. There is nothing special about this matrix, just some matrix. And let's see what do we have this conversation first. Let's look at a little bit of its rows. So what would be the first row of it? So A1, so this is the this is ith row, I is 1 at this case, and comma, separating rows and columns, and then for columns I put the colon there, meaning that that's the bullet notation, columns run free. And yes, indeed, I get the first row. 1, 0, 0, 2, 0. You see it's that. So then the second row, yes, it works as it should. Again, what we have here, then let's look at the columns. So now I want to look at the first column, for example. It's 1, 3. Let's look at the second column. Sorry, rows run free in the second column. So first is rows, then columns, and it's again. And note that since I only asked these and not assigned the values to any variable, then it uses this uns, and the uns changes all the time, of course. Let's try taking the sixth column, and of course there are only 5 columns, so I should get some kind of error message, and yes, I get out of bound, and then it says that the dimensions are 2 times 5. So this is how we refer to rows and columns with this colon notation. Okay. Let me exit this Octave and let's get back to the notes. So this is how rows and columns work. There is actually even a more complicated way of looking at matrices. So we can take a submatrix or block out of it. And this is where things get complicated, and but unfortunately this is a powerful tool that we will use later, so it's a good idea to at least consider it a little bit at this moment. So if we have a matrix A and 2 vectors, so v1 and v2 are now vectors, and there is this cutting, maybe you should call this cutting construct. So A, and then the arguments here are not numbers but vectors. And maybe it's actually better, it was stupid of me to close this Octave, let me open it again. How these cutting matrix blocks with this construct works. So let's have some matrix A here. Again, I try cut and paste it. Now it doesn't look too good for some reason. Okay. So it's 1, 1, 1, 2, 1, 3, 1, 4 first row, 2, 1, 2, 2, 2, 3, 2, 4 the second row, and 3, 1, 3, 2, 3, 3, 3, 4 for the third row. Okay, that looks good. And what happens next? Now I define 2 vectors. So what is the vector? Vector is of course a matrix that has only 1 row or one column. And if it's only have one row, it's a row vector, and only 1 column, it's a column vector. So that's what they are. So V1, I just define this. Now this both will be, I'm not sure if there will be row or column vectors, we'll see soon. It's just 1 and 3. So it's a vector, row vector with two elements. First element is 1 and second element is 3. Okay. And V2 will be similarly a row vector, but now it's 3 and 4 are the elements. Okay. So now I have defined matrix A, vector V1 and vector V2. And what happens next is something very funny. I look at this matrix A, at the elements V1 for the rows and V2 for the columns, but they are both vectors. So let's see what happens. So this is, I get a matrix. But what is this matrix? What's the meaning of this? And the meaning of it is, well, it's you might guess it. So I'm looking at all the rows defined by this first vector and all the columns by this second vector. I could actually, I didn't have to introduce the vectors. I could put the vectors here also. Let me put them here and a little bit of spaces so you can see what happens. So what was the V1? It was 1 and 3, and what was the V2? It was 3 and 4. So what's the idea here? So this would of course give the same as here, and indeed it does. And what happened? So I told to take from this A is here. It's this well, not big, but it's the biggest matrix here. And I asked to take first and third row. So I will cut the first and the third row. And then I ask it from the columns to cut into the third and fourth column. So this column and this column. So we take from these columns first and third row. So 1, 3, 1, 4, and 3, 3, 3, 4. And indeed, this is what you have. I could have also, for example, take the first row and third row and all the columns. So it works like this. Okay, as you see, I think this is, in principle, this is very simple. It's just like with you have this. If you have a matrix like that, you can cut it and paste this way or whatever you do. That's what we are doing. We are doing cutting and pasting really, but it can be, because a lot is done in a few commands, so it can be a bit confusing and complicated easily. And indeed, we can of course use this as assignments. So let's I clear the screen. So we had this A, we had this V. Sorry, V was undefined. So let's have A here and V1, and I use now the comma. So I ask both V1 and V2 what they are. So A, V1, V2 was 2 by 2. Okay. And just to show that how this can be complicated is that now A, V1, V2 is a 2 by 2 matrix that is a subset or submatrix here. And I can actually, since it's 2 by 2, let me put it, I assign that A, V1, V2 to be 2 by 2 zero matrix. And you see what happened. Now I had the original matrix was this, but now the matrix is changed so that at the places V1 and V2 I want to have zeros. So the zeros went here. Okay, now why would you want to do that? Well, turns out that surprising that in many cases in a programming this is exactly what you want to do. At this point, let us just leave it as it is. So now you have seen how this works, and yeah, we have maybe a little bit of exercises of them, but in later we shall just see that this is useful. All right, so that was what happened was submatrices. That is, we were cutting matrices, we were taking rows and columns out of it, and as I said, it can become very quickly very complicated, very tricky. Now, block matrices are actually in some sense the opposite thing. So what we want to do there is what we want to not to cut matrices but paste them. And now the only thing is how to paste them is how do you paste above or below or right to the left. That's basically the four corners, the four possibilities, and it works extremely in a simple way. So we'll just have a example 2.13 block matrix. So here again I've just decided to have some matrix A, it's this kind of matrix, B is this kind of matrix, actually a vector, but as I said, vectors are matrices. C is this kind of vector, and I is this identity 2 by 2. And here also I should point out, maybe I have pointed out this somewhere, so whether vectors are row or column vectors, I have decided in this course that unless otherwise stated, all the vectors will be column vectors. So like this. This is just the convention that I used. There is nothing too deep or fundamental about it. I just for some reason I like column vectors better. Okay, so then we want to construct the following matrix. Let me call it T now, T for tableau, table. So that I have first the C as a column vector, but as a row vector, so it's C transposed. And then I have number 1 here. Then I have below it the matrix A, then the identity matrix, and then the vector B as a column vector. So if you just paste them together, you can write them in the post-it notes. I've shown you the post-it notes. You can write each one of them on a small note and then paste them if you wish. So you get something like that. And of course the only problem here is that the dimensions have to be correct so that this builds up a nice rectangle. Now the question is, how do you do this with Octave? And you might think that this you just write this so that you put them together and put the columns. And could it be this easy? And actually yes, it could, it would, it will be this easy. So let's do that now. So the only thing, let's clear the console, and there are some, now there are some A and whatever. Let me clear all of those. So now we start with everything cleared. So the biggest job here is just to write down these A, B, C, and whatever they are. So let me try a copy paste to speed up this. Oh, the copy paste. You can see that there is a problem with copy paste. Now this is 1 1. Now I want to have an 11. So it doesn't always work, this copy pasting for a PDF file. But this is A. Is it now what it should be? 1 1 1 2 1 3 2 1 2 2 2 3. Yes, that's what it is. Let me do B then is, let's not copy paste, this not working, 760. And then the next row is minus 98. Let's see. Yes. And now I could actually put here this, so it will be column vector. Nothing wrong with that. But of course I can put it this way also. So make a row break there. Okay, now I have a column vector B is the correct. Then let's see C. C would be 2 4 0 4 0. Okay. Yes. Okay, let me do this with the quotation mark, single quote. Okay. What else do we need? Then there is I. So it's 2 times 2 identity. So now I have all the A, B, C, and I. And then I would like to construct a new matrix T that's pasting these together. I should also point out here that again this might look like a kind of boring, stupid exercise. Why would anyone want to do something like that? But let me assure you, this is something that these kind of things are something that we really want to do in operations research, or linear programming to be exact. So how do we then define T? So T, again T capital, let it be something. Let's have the brackets there. So first we have a C transpose. So C transpose like this. What's next? Then we have just number 1. Okay, it's number 1. And that's the first row. Then comes the second row, so we have a semicolon there to separate the rows. And then we have what? We have A, matrix A, followed by the identity matrix that we have defined, capital I. And then there is vector B, which is a column vector, so it's just like this. Okay, and now a little prayer, and let's see, does it work? Oh, it did. So T indeed, what we have here is indeed what we have here. So it worked. So here we have, and the rest of the page there is the same. Well, basically the discussion we just did with GNU Octave is copied here in the lecture notes. So you should try this on your own and see that if you really get the same results. And yes, so then a little bit of exercises. So these are really just exercises for you to see that you can pretty much replicate what we had in examples. So there is nothing really too deep about these exercises, but something that I think it's good to have these simple exercises without any theory or story about linear modeling, where we then actually later use this. So this is just a very straightforward, the first one I think. So there is a certain matrix given there, and again I've used these numbers that are so that it's easy to see which number is which element in the matrix. And the simple question I ask, what is the A, where the rows is a vector 2, 3, and the columns are a vector 1, 6. So I think this is relatively straightforward to do. Then there is exercise 115. Here is a new construct for us actually. So we already seen the colon notation in one way. So the colon was to say that something runs free. And as with semicolon, also colon has 2 different meanings in Octave. So the first one we've seen, it was the runs free, or corresponding the bullet notation in mathematical formulas. Now there's a construct that says n colon m. And this builds a vector of successive indices in the following way. So n colon m is a vector with elements n, n plus 1, n plus 2 up to m. So for example, 2 colon 5 is this kind of vector. So let us play around with this also a little bit. So 7 colon 9 is like this. 0 colon 10 is like this. Okay, minus 5 colon 3 is like this. Okay, so you probably
understand how this works. There is a more complicated version of this also. I could put minus 1.1 like this. Well, we don't have need for this, I don't think so, but just there for your fun. So usually we just use it like this. From some number, say 2 to some number 5 comes the following indices. It's if you have done any programming, you will know about for loops or something like that, then you will obviously recognize that this is kind of a natural thing to have. Okay, but then combined with this is a slightly more complicated exercise than this 2.14, but not too much. I'm just simply asking for you that. So a matrix A is given. It's like this. And then, okay, apparently there is a kind of typo here. It's 1,6, it should be 2,6, but it doesn't change the exercise. So let us have it like that. That's not, I mean, the numbers are just something there. It's not so important what they are. And my question is for you, what is the A 2:416? Again, I think it's relatively straightforward exercise, but something that it's good that you do it at least once to see what happens. So that was the chapter 2. So let's go back to the contents to see where we are. So now we have seen how to use Octave as a calculator, how to run simple calculations with variables, and consider a little bit of matrices and vectors, and especially cutting and pasting matrices, block matrices and matrix blocks. And in the next video lectures we go to the so-called M files. See you there. Bye bye.